everyone. My name is Sherman Ikemoto. I'm a managing director at Future Facilities. I'm located in San Jose, California, and Future Facilities is a software company that provides simulation software for data center management, data center design. Today we're going to be talking about the challenge of data center management and a new approach to data center management based on the concept of a digital twin of your data center. So before we start, let's talk about what a typical data center operation is trying to achieve. What a typical data center operation is trying to achieve is not really straightforward. This is because data center operations must meet multiple objectives at the same time and at different levels of the operation. At the level of the building blocks of the data center, which are the network, IT configuration, power distribution, cooling system, etc., each of these have individual requirements to meet to fulfill their obligation to the data center operation. But at the same time, the interactions between these building blocks must be coordinated in a way that ensures that the data center as a whole meets its performance requirements. So needless to say, the data center has a lot of moving parts that must be orchestrated to ensure that requirements are met across these building blocks and also through the management stack. And over the years, there's been a lot of focus on tools and techniques that simplify the work that is done for each of the building blocks. But what hasn't been addressed are the tools and techniques for orchestrating these building blocks to achieve the best outcomes for the data center overall. And this presentation is about the challenge of data center management with respect to orchestrating these building blocks. To start, let's confirm what the building blocks of the data center operation are trying to achieve together. What is needed from the data center overall? At the highest level, there are really only three objectives of data center operations. They are, number one, to protect the IT services from environmental harm, to make sure every IT unit is getting the power, cooling, airflow, etc. that it needs to operate reliably. Number two, to operate quickly to satisfy the time constraints of the users of the data center. And number three, to operate at the lowest possible cost by using the expensive data center resources as efficiently as possible. So those three things are what data center operations is trying to achieve overall. And why are these objectives a challenge to meet? It's because so many things are changing in the data center as a result of business operations. The situation depicted in the images is common, where a data center is designed for a very specific IT configuration, and over time, the users of the data center stray from this configuration, sometimes drastically. This situation within data centers, the fact that they change all the time, can be illustrated in a number of ways. One way is to take note that organizations like ASHRAE exist to try to help data center operators foresee the changes that are coming their way in terms of the characteristics of the IT equipment that operators will have to deploy and deal with. So here is a server power trends chart from ASHRAE that is meant to show the operator how power density in servers will change over time. So if you're an operator and you're designing a data center in 2010 and you want to operate that data center for 10 years, you will likely have to plan for a 20 kilowatt range of IT equipment. But if you're operating that data center and then now have to plan for IT equipment in 2015, the roadmap for IT equipment as published by ASHRAE changes completely. A lot of the power densities are lower. ASHRAE is reporting the information in a different way. They've broken it out by server type, and the trends aren't as steep. So if you're planning now in 2015 for the same equipment, you may have to plan only for a 2.5 kilowatt range of IT equipment. So these changes, the changes on the IT side, the changes in IT technologies are very rapid. Much more, and they change much more frequently than the data centers that have to accommodate these units of IT equipment. And as the users of the data center stray from the design configuration, the loading on the data center changes. And these include the demands for space, power, cooling, airflow, and even weight-bearing capacity on the data center floor. So this is a trending of power density from IBM CMOS mainframes dating back to many generations previous, all the way up to the current generation Z14 units from IBM. If you're planning to operate a data center for 10 years over multiple generations of IBM mainframes, you have to be able to accommodate widely changing power densities in those units. And that also affects other characteristics of the unit, such as airflow and weight and other physical characteristics. This information comes from the 2020 State of the Data Center report from AFCOM, where average rack densities are going up significantly in recent years. It's now the most common rack density is around 4 to 6 kilowatts per cabinet, but we're seeing anywhere from 7 to 20 plus kilowatts per cabinet showing up in data centers. And the respondents who were questioned for this study are saying that, or 26% of them are saying that their rack densities have increased significantly in the past 3 years, and 42% say they've increased somewhat. So the trend is toward higher density cabinets in terms of power, as reported by AFCOM. But these aren't the only changes. There's many changes in the data center that impact performance. These include things like the virtualization of software that runs on the computing hardware, which enables dynamic application loading and changes the power distribution of the data center as a function of application loading. Other changes, physical changes that impact performance, are things like the adding and removal and changing of cabling, maybe manufacturing discrepancies of the cooling and power equipment in the room that don't quite match what the spec sheets are saying in terms of performance. Floor plan changes, even conflicting management requirements. All of these contribute to the challenge of managing the performance of a data center. But the most pressing impact of change in the data center is an increased risk of IT service outages due to shortfalls in the supply of resources from the facility. To avoid IT service outages, many data center operators supply extra resources as a safety margin against potential failures, and to avoid extending the time and cost of planning data center changes. These safety margins are based on experience that has been developed over time, rules of thumb, so-called best practices, and basic calculations. And these methods are quick to implement and can be effective at preventing outages, but they are very crude and they end up wasting significant amounts of resources, data center resources, due to the magnitude and the uncertainty of the planning information they provide. One study showed that hyperscale data centers leave 14% of its capacity stranded. Another study showed that enterprise and colo data centers strand 44% of their capacity, which means they are building 2 data centers for every one they actually need. Ultimately, the problem comes down to cost and a business decision about how much of a cost overrun is acceptable to the data center operator. This is where the concept of digital twin comes in. Digital twin is a new approach to data center management that is based on a computer model, a virtual replica of the physical data center. To give you a sense of digital twin, let's walk through one alongside its real-world counterpart. Digital twin is your data center, replicated in a virtual world. It's built from virtual representations of the power, IT, and cooling system components that enable the data center to function. These components can be represented at different levels of detail, depending on the application. At the finest level, components like this blade server can be represented visually and operationally in full detail. Now, on the surface, digital twin looks like a DSIM tool. But what makes digital twin completely unique is a built-in physics-based simulation capability that mimics the physical operation of its real-world counterpart. So this is interesting, but why is it important? It's important because data center management today is split up into silos that see the data center in parts, but not as a whole. And in this example, the silos set their requirements in isolation, but they are not able to foresee the impact on the data center with all of the parts working together. And this leads to a performance problem that they were unable to see coming. So if we rewind this example, we can see the impact of managing with a digital twin. So digital twin is able to engage all of the silos in the planning of a change in the data center. And this does 2 things. Firstly, it simplifies data center management. It consolidates the data and decision points across silos and through the management stack. And so in this example, digital twin enabled 4 options to be evaluated in far less time than a conventional approach takes to evaluate 1. But more importantly, as a simulation of the data center, digital twin elevates the focus of management from their silos to the data center as a whole. So in this example, Plan 1 will fail to meet cooling requirements, Plan 2 will fail to meet power requirements, but Plans 3 and 4 meet all requirements. In terms of resource utilization, Plans 1, 2, and 3 will use way more airflow than needed and waste it. Only Plan 4 has an acceptable resource utilization profile. So by process of elimination, Plan 4 is the obvious way forward. In addition to simulation, digital twin has 2 other important features. One is that digital twin is configurable. It can be implemented standalone or as a simulator for another data center management system. And this is possible through data exchange APIs that automate data transfer. It is also connected to a virtual replica of the entire data center ecosystem, where a digital twin of any component that goes into a data center can be found and brought into a simulation. So to sum up, digital twin represents a new approach to data center management that is based on a simulation of your data center. It's the only approach that enables data center performance to drive management decisions. It simplifies data center management by consolidating data and decision points across silos and through the management stack. It's configurable. It can be deployed standalone or as part of an existing data center management system. So now we can take a look at digital twin in action to see how it impacts specific companies that are actually using digital twin today. So this example comes from a major healthcare provider in the United States, a very large company in terms of healthcare. The web traffic is very high. A lot of business is done on their website, and they're actually expanding and adding new services based on AI and other modern technologies that are available now. This company operates about 16.7 megawatts of capacity. It's distributed over 10 data halls and 245,000 square feet of white space. And the reason this company brought digital twin into their processes is the same one that we described earlier, where their data centers were designed for a certain IT configuration, a certain power density, a certain airflow utilization requirement. And under those conditions, the performance of their data centers would be good, would be acceptable. But those conditions never are permanent. The business requires new types of IT equipment, new applications. These change the loading on the data center and therefore impact data center performance. And again, one of the main drivers is the need to accommodate high density IT equipment, like the IBM Z14 or an Oracle Exadata unit, whose power densities are much higher than the data center was designed to handle, and also the airflow requirements for those units. And at the data center level, this company expressed the same thing that we had talked about at the beginning, where they're trying to maximize capacity utilization of their 16.7 megawatts, protect the reliability of the IT services running within those data centers, and responding quickly to customers when new applications, new IT hardware need to be deployed. This company implemented digital twin starting back in the beginning of 2017, and they've been using digital twins in their data centers for 2 years now, going on 3. And what we see in the trends, in the performance trends, is a positive performance trend in terms of reducing stranded capacity overall from 2017 through what they expect to achieve by the end of 2020. So stranded capacity is the amount of IT load that they can safely load in their data centers, the amount of IT load that is being exposed to either high temperatures or non-redundant power in their data centers. And that trend is going down. So they're actually able to use more capacity today than they were able to use when they started. At the same time, they increased their the resilience of the IT hardware in the data centers. So close to 5% of the hardware in the data centers were exposed to bad environmental conditions, and they reduced that over 2 years to effectively zero. And this was also occurring when they were rapidly changing the IT configuration. The total power dropped slightly, but they installed a lot of high density equipment and took out a lot of legacy equipment in these rooms. At the same time, they're also managing PUE. There was a drop in PUE from 2017 to 2018, a significant one. The PUE went up slightly in 2019, but at the point of taking these readings, taking these metrics, they were in the middle of a number of changes in their data center, and they expect to be able to bring PUE back down significantly by the end of 2020. To summarize the impact that digital twin has had on their data center operation, in 2017, they were projecting about a 25% stranded capacity. And they were going to strand 25% of their UPS power because they would have run out of air if they were to continue using resources at the same rate as they had measured in 2017. But by the end of 2018, they recovered a significant amount of that stranded capacity by changing their data centers so that they use airflow much more effectively and efficiently, freeing up a lot of UPS power for use by IT equipment. In addition to increasing the available capacity and increasing also the resilience of the IT equipment and decreasing PUE, Digital Twin brought these capabilities to this company: a consistent and scientific methodology to manage their data center resources, to manage their IT resilience, and the interrelationships between the subsystems or the building blocks of the data center. They automate the communication now between IT, facilities, engineering, and management in the planning process. It's all available instantaneously from Digital Twin. There's no need to pass information from one system to another. They gained a new and powerful power system failure analysis capability that they didn't have. So this allows them to run closer to the margin on power, because now they know exactly what will happen under failure scenarios. And the same goes for cooling. They're able to run cooling failure scenarios as well. They have the Digital Twin is connected to their IT workflow, and this gives them accurate inventory reporting on all of the assets in the data center. The data center is synchronized with Digital Twin at all times. And they are also able to benefit from a single view of power and temperature monitoring data within the 3D model of Digital Twin. They gained significant time savings from Digital Twin as well. In deployment planning, when computational fluid dynamics modeling is involved, they went from 4 weeks plus down to 1 week or less. In some of the reports that they generate on a regular basis, they went from 2 weeks plus down to a push of a button. The power system failure analysis now is also available with a push of the button. It's computational fluid dynamics analysis for airflow planning and cooling planning, push of a button. Power deployment planning, push of a button. Also space planning, push of a button. They estimated the return on investment for 3 years of using Digital Twin, and this includes the setup cost, the cost to set up the Digital Twin in the first place. This ROI for the next 3 years will be even greater. it'll be greater because the setup costs are already done. And now all that's left every year is a recalibration in order to make sure that Digital Twin is recording all of the changes that occur over the course of a year. In another case study, Citigroup teamed up with NYSERDA, which is the energy company in the northeast of the United States, to see if Digital Twin could be used to drive improvements in data center performance with a focus on energy efficiency. And this was presented at DCD in New York in 2017. The study was performed on a data center in New York City, 40,000 square feet, built in 1986. At the time of building and calibrating the digital twin model, the facility was loaded up to about 55% of its full IT loading capacity. After building and calibrating the digital twin model, it was used to look for areas where the resources could be used more efficiently and more effectively, so that they can eliminate resilience problems and also wasted resources at the same time. And these are snapshots of some of the examples. So custom blanking solutions were developed for cabinets that were not using airflow resources very efficiently. Here's another example of custom blanking, where after installing the custom blanking solutions, inlet temperatures dropped significantly to the IT equipment, which increased resilience of the IT equipment, and also allowed them to raise chilled water set points and raise air temperatures to save on energy, and also to extend, make more airflow available to be used by future IT equipment. Here are the performance results for the project. It occurred over 12 months, and over that period of time, they increased the resilience of the IT equipment significantly, both under normal operating and failure scenarios. They decreased PUE to their goal of 1.61, and they were able to free up all of the capacity in the room because the air that was being used was not wasted. It was there was very little waste of air, and all of that, all of the rest of the air that was available could be used to cool equipment that would come in the future. In another example, CBRE, who was managing a Bank of America data center in the UK, did a similar study, and they wrote a paper on it that is available for download from the Future Facilities website. The author was Gary Kane. He was a data center manager at the time, and this paper is again about using a digital twin to improve performance in a Bank of America data center. They first described the process that they built around digital twin, where if a change comes in and the requirements for resources are different from what the data center was designed for, they do a simulation in order to optimize the design of that change so that resources are used efficiently and so that resilience requirements are met at the same time. They identified a number of areas in the data center where performance was not good, either because of hotspots or wasted resources. And these are some of the changes that they made to the data center in order to raise performance of the room. They switched from return to supply air control, and they did this using the digital twin first to make sure that nothing bad was going to happen in the data center. So they wanted to do it safely first before making the actual change in the real data center. They unified their fan speed control. They built some bespoke blanking based on the simulations in Digital Twin. They rearranged and added different types of floor grills so that the airflow supply matched the airflow requirement from the IT equipment better. And these are the improvements that they were able to make. So the reliability or availability of the IT equipment went from 97 to 100%. That means all of the units in the data center, after making the changes, got the resources they need to operate safely, either airflow, cooling, power, etc. They dropped their POE by 7%, and they increased the data center's ability to support IT equipment by 10%. They did a in-depth calculation on the value of this exercise, and CBRE estimated a return on the use of Digital Twin of $10 million, mainly due to the increase in the amount of capacity that the data center could hold. Thank you for watching this presentation about Digital Twin and how it addresses the challenge of data center management. I hope you enjoyed it. If you had any questions, you can either visit the Future Facilities website to learn more about Digital Twin, or you can email me at the email address you see on the screen, and I'll respond to any emails or any questions that anybody has. Thank you for watching.